I agree with William Faulkner, but I think his statement requires more context. Because it is not the idea of the past, but the themes that live within the past that continually find their way back to the present. We can see how greed changes in how it looks while still producing the same outcome, which is inequity. Until greed is eventually defeated through progressivism and effectively sealed away through policy reform like labor laws during the Gilded Age, it appears to me that we as a society continually fight the theme of greed, because greed represents the constant threat to equity and justice that our founding fathers sought to create through the Declaration of Independence in 1776. Perhaps equity and justice will one day be a reality for all men and women. Once we work through every shape of greed there could be in existence, and ensure that policies are in place to prevent that same shape of greed from ever reoccurring. Lastly, I think that this eternal battle truly represents and defines what the American experiment is. A morally persistent struggle against all odds, but more so, being human greed in all its unknowingly infinite shapes. Paper Trail, Episode 3, Ghost in the Machine. In the last episode, we built a pipeline that extracted 1.18 million entities from 2.1 million government documents. This episode is about what happens when the machine gets it wrong, and how we know. 1,018,121. That is how many entities in this database appear exactly once, one mention, in 2.1 million documents. And then, nothing. 42.7%, nearly half of every name, every organization, every location the pipeline extracted, appears once and never again. Some of these are real people mentioned in a single document. Some are aliases. Some are OCR artifacts, phantom names generated by a machine misreading a scanned page. This episode is about those phantoms, how the pipeline creates them, how we find them, and what it means when nearly half your data might not be real. Nearly half the entities in this database are ghosts. They exist in the data, they do not exist in reality. A ghost entity is a name that the pipeline believes it found, but that was never actually written in the original document. The machine read something that wasn't there, and once it enters the database, it looks exactly like every other entity. It has a name, it has a mention count, it has relationships to other entities. It just isn't real. Here is the pipeline from episode 2. 16 scripts, 8 stages. But look at this path. OCR transcription converts scanned images into text. Named entity recognition finds names in that text, and between them, nothing. No verification layer, no check that the text OCR produced actually matches what the document says. NER trusts OCR completely. Whatever OCR outputs, NER treats as ground truth. If OCR hallucinates a word, if it turns a smudge into a name, NER will extract it, classify it, and add it to the entity table. The pipeline has no way to tell the difference between a real name and a phantom. Optical character recognition reads images of text and converts them to digital characters. When the source is clean, crisp print, high resolution, no creases, it works well. But the Epstein corpus is not clean. It contains faxes from the 1990s, carbon copies, handwritten flight logs, forms that have been photocopied, scanned, and refotocopied. When the source is degraded, OCR guesses. Faded ink produces wrong letters. Creased paper merges adjacent characters. low-resolution scans turn letters into ambiguous shapes. And blank form fields, the most insidious vector, have pre-printed labels that OCR reads as filled-in content. When the guess produces a real word, the hallucination becomes invisible. The pipeline treats it as fact. The pipeline is a trust chain. Each stage trusts the output of the stage before it. OCR trusts the scan quality. NER trusts the OCR output. The graph trusts the entity table. Analysis trusts the graph. But no stage verifies backward. NER does not check whether OCR read the document correctly. The graph does not check whether the entities it connects actually exist. A single hallucination at the OCR layer propagates forward through every downstream stage, unchallenged, unchecked, accumulating relationships and mention counts as if it were real. We have identified 3 systematic hallucination vectors in this corpus. First, blank government forms. These forms have pre-printed field labels, name, address, persons or non-resident alien. When the form is never filled in, OCR reads the label text as if it were content. The word Poland that appeared in OBS 5 came from a blank field labeled persons/non. Second, repeated boilerplate. Document headers and footers are printed on every page. Across hundreds of pages, OCR occasionally mangles the same header into different fragments. Resource Management Account, a standard UBS account type, became Krakow. Third, degraded handwriting. The flight logs in this corpus are handwritten. OCR struggles with cursive, and when it guesses wrong, it produces names that look real but aren't. This is how a phantom pilot named Dave Limmer entered the database. This is why ghosts are dangerous. A phantom entity has everything a real entity has. It has a name. It has a mention count, because the same hallucination repeats across documents with similar degradation. It has relationships, because it co-occurs in the same documents as real entities. It occupies a position in the network graph. Looking at the database, you cannot tell the difference. The phantom sits right next to Jeffrey Epstein, right next to Deutsche Bank, right next to real names, and it looks exactly the same. The only way to tell is to go back to the source document and read it with your own eyes. Observation 5. On January 14, 2026, the NER pipeline flagged an unusual location entity, Poland. It appeared in a Deutsche Bank Know Your Customer form, a compliance document that banks use to verify the identity and nationality of account holders. The initial assessment was significant. A Polish national associated with an Epstein account at Deutsche Bank. A new country in the network, a new lead. The document reference EFTA 01268-833, page 17. A single page in a multi-thousand page collection of Deutsche Bank compliance records. Here is the source document, EFTA 01268-833, page 17. It is a Deutsche Bank KYC form, a standard compliance document used to record the identity of an account holder. You can see the pre-printed field labels, name, address, date of birth, nationality. And you can see something else. The form is blank. No information was ever filled in. The fields are empty. There is a closed stamp dated December 17, 2019. This form was opened and closed without completion. There is no account holder. There is no Polish national. There is only a blank form. Here is the field. The pre-printed label reads, persons/non-resident alien. That is a standard KYC classification field. It asks whether the account holder is a U.S. person or a non-resident alien. The OCR engine read the partial text persons/non and converted it to Poland. The NER model then classified Poland as a location entity. And just like that, a blank form field on a closed compliance document became an international lead. There is no Poland in this document. There never was. Persons/non becomes Poland. The OCR engine saw letter shapes that roughly matched POLAND. The NER model saw a capitalized word that matched its training data for geopolitical entities. The database accepted it as a real location. No stage questioned it. No stage checked the source. 1 misread. 4 pipeline stages. A phantom location in the database. Here is why this matters beyond a single retraction. That one hallucination, persons/non becoming Poland, did not appear once. It appeared 70,578 times across 17,603 documents. It ranks 110th among all location entities in the database. How? Because the same KYC form template appears across hundreds of Deutsche Bank compliance documents. The same blank field, the same pre-printed label, the same OCR misread, repeated thousands of times. Each time, the pipeline dutifully extracted Poland and added another mention to the counter. 1 blank form field, 70,000 phantom mentions, and a location entity that ranks higher than many real places in the Epstein network. Observation 5. On January 14, 2026, the NER pipeline flagged an unusual location entity, Poland. It appeared in a Deutsche Bank Know Your Customer form, a compliance document that banks use to verify the identity and nationality of account holders. The initial assessment was significant. A Polish national associated with an Epstein account at Deutsche Bank. A new country in the network. A new lead. The document reference EFTA 01268-833, page 17. A single page in a multi-thousand page collection of Deutsche Bank compliance records. Here is the source document, 190 pages of UBS account statements. Look at the header, Resource Management Account. That is the UBS account type, a standard classification printed at the top of every page. Not account holder information, not a location, a product label. It appears on page 1, page 2, page 3, all the way through page 190. The same 6 words repeated 190 times. Resource management account becomes Krakow. Across 190 pages of repeated headers, OCR occasionally mangles the text. Most of the time it reads correctly, but on some pages, degraded scans, slightly skewed alignment, it produces fragments. In one of those fragments, NER classified as Krakow, a city in Poland, appearing in Ghislaine Maxwell's financial records. an entity that exists in the data but not in reality, another ghost. This is the Retraction Protocol. It is documented and repeatable. Step 1. An entity is flagged, either by an automated anomaly or by the analyst reviewing high-value findings. Step 2. The source document is retrieved by its Bates number, the unique identifier assigned to every page in the corpus. Step 3. Visual inspection. The OCR text is compared against the original scan. What did the machine say? What does the document actually show? Step 4. Classification. Is this a real entity, an OCR artifact, or ambiguous? Step 5. If it's an artifact, the finding is retracted, marked with a full explanation of what went wrong and why. Step 6, and this is critical, the retraction is preserved. It is never deleted from the project record. OBS 5 is still in observations.md. OBS 6 is still there, marked retracted, with every detail of why. Future analysts reviewing this work will see what the pipeline got wrong, and they will know why. This is the leaderboard, the 25 most mentioned entities in the entire Epstein corpus, ranked by total mention count. Look at the colors. Green means the entity is real. Red means it's a phantom. Orange means it's a real entity with a corrupted name. Gray means it's noise, a tracking number, a legal suffix, a generic term. 12 of the top 25 entities in this database are phantoms, noise, malformed entries, or duplicates, nearly half. The third most mentioned entity in the entire corpus, above American Express, above the United States, above FedEx, is UTC, a time zone abbreviation. 4.8 million mentions. Not a person, not a company. A 3-letter time zone code that OCR found in document metadata and NER classified as an organization. UTC. 4,838,546 mentions. The third most mentioned entity in the entire Epstein document corpus. It is not a person. It is not a company. It is not a trust, a shell corporation, or a financial institution. It is Coordinated Universal Time, the International Time Zone Standard. 3 letters that appear in document metadata, email headers, and timestamp fields across millions of pages. The NER model classified it as an organization, and so UTC, a time zone, sits in the entity table above American Express, above the United States of America, above FedEx. This is what contamination looks like at scale. LLC, 2.2 million mentions. Limited liability company, not an entity, a legal suffix. Every time the NER model encountered a company name ending in LLC, it sometimes split the name and extracted LLC as a separate entity. JEGE LLC becomes JEGE and LLC. Southern Trust Company LLC becomes Southern Trust Company and LLC. Each fragment is tiny, but across 2.1 million documents, those fragments add up. 2.2 million mentions of a 3-letter legal abbreviation, sitting in the entity table as if it were a real organization. AC count, 1.8 million mentions. It is not an organization. It is the word account misread by OCR from financial statement headers. The capital A, lowercase CCOUNT. OCR saw the word account and NER extracted AC count as a proper noun. Macintosh, 1.5 million mentions. The Apple Macintosh computer used to create or scan many of these documents. Its name appears in PDF metadata, creator, application, operating system, and NER dutifully extracted it as an organization entity. iPhone 8, 1.2 million mentions. An iPhone 8 device identifier embedded in document metadata, classified as an organization. Incomey, 1.3 million mentions. The word income misread from tax document headers. Combined, 5.8 million phantom mentions from 4 entities that are not persons, not organizations, not locations. They are scanner metadata and OCR artifacts. 438,428 entities in this database contain special characters that should not appear in a name. Brackets, slashes, bullet points, numbers concatenated with text. 420 entities have names of 1 or 2 characters, too short to be any real person, organization, or location. Look at these examples. Marcinko Richard, ampersand, bullet, 2154. That is an entity record. David Rogers MS0/4 Krebra. Nadia Marcinkova 00,000.00. That is a dollar amount concatenated with a name. These are not edge cases. 438,000 records. 18.4% of the entire entity table is visibly corrupted. Here is the frequency distribution of every entity in the database. The left bar, singletons, entities appearing exactly once, towers over everything else. 1,018,121 entities, 42.7% of the total. Some of these are real, a person mentioned in a single court filing, a location referenced once in correspondence, but at this scale, over 1 million singletons, a significant proportion are ghosts, OCR artifacts, NER fragments, names that were never written in any document. This is the ghost army, over 1 million entities that may not exist, and every one of them sits in the database, indistinguishable from the real names without manual verification. Every number we reported in episode 2 is inflated. When we said 1.18 million entities, that includes phantoms. When we said 432,000 persons, that includes OCR artifacts like Dave Limmer. When we said 670,000 organizations, that includes UTC, LLC, ACC, OUNT, and Macintosh. When we said 29.5 million relationship pairs, that includes connections to ghosts. This is not a failure disclosure. It is a calibration disclosure. The pipeline found real intelligence, real names, real connections, real financial records. It also created noise. The job now is to tell them apart. And that starts with the case studies. Dave Limmer, 4,995 mentions. A person entity in the database, classified as a pilot in the Epstein flight logs. Dave Limmer does not exist. There is no pilot by that name. There never was. The flight logs in this corpus are handwritten, pen on paper, cursive script, often degraded by years and photocopying. The real pilot's name is David Rogers. He flew Epstein's aircraft for years. His name appears hundreds of times in these logs. But OCR cannot reliably read cursive handwriting. On some pages, David Rogers became Dave Limer, and the pipeline created a second pilot, a phantom, with nearly 5,000 mentions, indistinguishable from the real pilot in the database. Now look at the real pilot, David Rogers. One real person, 76 entity records in the database. The clean version, David Rogers, has 7,387 mentions, but his name also appears as David Rogers with 2,187. David Rogers, open parentheses, pilot, 230. David Rogers, card, 200. David Rogers, MS0/4 Krebra, 152. That last one is OCR, reading the handwritten text and the adjacent column data as one continuous name. Every variant is a separate entity record, each with its own mention count, its own relationships, its own position in the network graph. If you search for David Rogers, you find 7,000 mentions. The real number, scattered across 76 variants, is nearly 12,000. One real pilot, 76 ghosts. Not all ghosts come from OCR. Some come from the analyst. Observation 1 flagged a FedEx invoice showing a shipment to someone named Robert in Hawaii. The pipeline had also identified the underground cartoonist Robert Crumb in the entity table, an artist known for explicit illustrations. The initial assessment, a connection between Epstein and R. Crumb. It was wrong. Robert Crumb has lived in southern France since 1991. He has no connection to Hawaii. And Art of Women, the item referenced in the shipment, does not exist as a Crumb work. The shipment was to a different Robert. This is a different kind of ghost. The OCR was correct. The NER was correct. The entity was real. But the inference, the leap from Robert to Robert Crumb, was a human error, not a machine error. OBS1 is marked refuted. The Retraction Protocol caught it before it became a public claim. Nadia Marcinkova, one real person, a key figure in multiple Epstein cases. She has 48 entity records in the database. 48. The clean version, Nadia Marcinkova, has 624 mentions, but she also exists as Marcinkova alone, as Nadia bracket Marcinkova. OCR read a page artifact as a bracket. As Nada Marcinkova, the I became an A. As Naba Marcinkova, DIA became BA. As Nada Tor Nadia bracket Marcinkova, where OCR read a deposition correction as part of the name. And then there's Nadia Marcinkova JPG. That is a JPEG file name. The pipeline extracted a file name, the image file of a document scan, as if it were a person's name. One real woman, 48 database fragments, and no automated way to know they are all the same person. The subject of this entire corpus, Jeffrey Epstein himself, has 10,600 entity records in the database. 10,600 entries for one person. The clean version has 5.9 million mentions, but Jeffrey E. Epstein NY, where NER absorbed the state abbreviation, has 972,000. Jeffrey E. Epstein closing, where NER ate the first word of a bank statement header, has 186,000. And then it gets worse. Jeffrey E. Epstein closing date 09/24/10. The NER model consumed an entire bank statement header, name, the word closing date, and a specific date, and classified the whole thing as a single person entity. 29,472 mentions. Jeffrey E. Epstein DWC count, that is DW account, a Deutsche Bank account type, with OCR mangling account into account, and NER absorbing the whole mess as a person's name. Look at this entity record. Name, Jeffrey E. Epstein. Closing date, 09/24/10. Type, person. Mentions, 29,472. This is a bank statement header classified as a human being. On a Deutsche Bank account statement, the top of the page reads, account holder name, followed by statement fields, closing date, account number, balance. NER could not find the boundary between the person's name and the statement metadata, so it consumed the entire line as one entity. Jeffrey E. Epstein, closing date, September 24th, 2010. A person, according to the pipeline. And because this header appears on thousands of identical statement pages, it accumulated 29,472 mentions. A phantom person with more mentions than most real people in this corpus. The flight logs are the hardest documents in this corpus. They are handwritten, cursive, pen on paper, often photocopied multiple times, each copy degrading the image further. OCR was designed for printed text, typed pages, laser printed forms, digital documents. It was not designed to read 1990s cursive handwriting on carbon copy flight manifests. The Chow-1 species richness estimator, the same tool we used in episode 2 to measure how much of the corpus we've mined, puts the flight log completeness at 23.2%. The corpus average is 63.7. The flight logs are nearly 3 times less complete than the average dataset. An estimated 4,275 entities remain undiscovered. Every misread passenger name creates a phantom traveler, and the real name goes unrecorded. Dave Limmer, Lauren Quine, which is actually Lauren Quintner, a New York attorney, and thousands more we haven't identified yet. This is the solution, or at least part of it. Script 8, the Vision Language Model. Qwen 2.5 VL, 7 billion parameters, running locally on a consumer GPU. It does not read documents the way OCR does, character by character, converting pixels to letters. It reads documents the way you do, as images. It sees the whole page, layout, structure, where headers end and content begins, whether a form field is filled in or blank. When it encounters handwriting it cannot confidently read, it marks it with a question mark, flagging uncertainty instead of guessing silently. When it sees a blank form, it reports the field as empty instead of reading the label as content. This is the verification layer that was missing from the pipeline, the node that sits between OCR and NER and asks, Is this text real, or is this a ghost? Entity resolution, script 19, is the tool that merges the fragments. It uses probabilistic record linkage, a statistical method that compares entity names, measures their similarity, and groups variants that likely refer to the same real-world entity. The 48 faces of Marcinkova become one cluster. The 76 variants of David Rogers become one cluster. 372,000 person records processed. 17,980 multi-entity clusters identified, groups of 2 or more records that Splink determined were the same person. 536,000 organization records. 63,000 locations. In total, 752,000 entities assigned cluster IDs. 519,000 distinct clusters. That's a compression from 2.4 million raw records to 500,000 resolved entities. It's not perfect. The thresholds are conservative. We'd rather miss a merge than falsely combine two real people. But it's a start. No single tool catches all ghosts. That's why the project uses a 3-layer defense. Layer 1, VLM reprocessing. The machine reads documents as images, catching blank forms and header absorptions that OCR missed. Layer 2, entity resolution. Statistical algorithms merge fragmented variants, connecting the 76 David Rogers records into one cluster. Layer 3, manual corroboration. The analyst pulls the source PDF and reads it with their own eyes. This is the protocol that caught OBS 1, OBS 5, and OBS 6 before they became public claims. It corrected 5 calibration dates that were wrong in the research literature. It identified Dave Limmer and Lauren Quine as OCR phantoms. It verified 8 property addresses against external government registries. It is not fast, it is not automated, and it does not scale to 2.4 million entities. But for the findings that matter, the ones that appear in this documentary, every single one passes through all 3 layers. And here is what's left. 863,000 email PDFs across datasets 9 and 11, 0% NER coverage, 0 entities extracted. These emails have never been read by the pipeline. Every ghost we've identified in this episode, every phantom entity, every fragmented name, every OCR hallucination, came from the 40.8% of the corpus already processed. The remaining 59.2% is untouched. When we process those emails, the entity count will grow. Some of those new entities will be real, names, organizations, locations that expand our understanding of the network, and some will be ghosts. The pipeline will create new phantoms, new fragments, new header absorptions. The ghost problem will get bigger before it gets smaller. That's why we built the mitigation stack first. Error log. This is the series' recurring transparency segment. Everything the pipeline got wrong. Everything that remains incomplete. Everything the audience should know before trusting the data. OBS 1, refuted. OBS 5, retracted. OBS 6, retracted. Entity counts from episode 2, inflated by phantom contamination. The 42.7% singleton rate is documented in this episode. VLM coverage, incomplete. Entity resolution, partial. Remaining risk, high. 863,000 unprocessed emails. Flight log OCR, degraded, 23.2% Chow 1 completeness. And the known unknown. We do not know how many of the 1,018,000 singletons are real entities and how many are ghosts. That determination requires manual verification. At this scale, it does not exist. Why do we show you the errors? Because errors disclosed are science, errors hidden are fraud. OBS 5 and OBS 6 are not deleted from the project record. They remain in observations.md marked retracted, with full explanations of what went wrong and why. Any future analyst who reviews this work will see what the pipeline got wrong. They will see how the errors were caught, and they will apply that knowledge to their own analysis. Deleting errors creates the illusion of a perfect system. There is no perfect system. There is only a system that catches its mistakes and shows its work. Every finding that survives in this series has passed through the same verification protocol that caught these three errors. That does not make the surviving findings perfect. It makes them tested. 1,018,121 ghosts, 3 retractions, 48 faces of one woman, 10,600 records for one man, a time zone that outranks the United States, a phantom pilot with 5,000 mentions. This is what happens when machines read documents. They find what's there. They also find what isn't. The pipeline is not perfect. It never will be. But every finding in this series, every name, every number, every connection, has been tested against the source documents. What you see in the episodes ahead are the findings that survived. Next, Episode 4, Willful Blindness, Deutsche Bank and $150 million. A single email from May 2013 that bypassed an entire compliance regime. $2.65 million in wire transfers to women with Eastern European surnames. 97 cash withdrawals at exactly $7,500 each.